Hello everyone, welcome to this tutorial. And we're going to be looking at how we can use the Google Sheets spreadsheet to help us perform flashy science experiments. And in particular, we'll see how we can use Google Sheets to record data, to do calculations on the data, and to create plots or graphs, and then to add straight line fits to those graphs. So the first thing we should do is, I've opened a new Google Sheets screen, so the first thing we should do is click where it says rename and name the spreadsheet. So I'm going to call it something simple here, Google Sheets tutorial. There we are. So I can click away from that and that's now saved. Now we should treat this spreadsheet like we would treat our lab book. So the first thing we should do, of course, is write down the date. So I'll put today's date in, 31st of March 2020, and also something descriptive that will help us to understand when we look back at this what it is that all of this means. So I'm just going to put in a tutorial for Google Sheets demonstration. There we are. And just like a lab book, we could also put in here some conditions of how we ran the experiment and so on. So we're going to put data in some of these columns to the right here. Now, I'm not going to actually run an experiment while I do this. I'm just going to make up some data. But hopefully you get the idea is that you can put your data in a similar way that I'll show you. So let's assume that we're going to do an experiment that maybe involves adding mass to something in our experiment, and we then measure a distance with a ruler. So we might do different tests. So I'm just going to label an area here and call this test 1. And I might make that in bold so that it stands out a little bit more. And then I'm going to use columns to the right of that for test 1 data. So we're going to add mass and then measure distance. So here I'm going to put a column heading of mass in grams, and next to it the distance in centimeters. There we are, and because these are headings, I'm going to highlight them both. So I've clicked and dragged across them both and then press the B to turn those into bold. Right, so the way that this made-up experiment works is that, let's say we add mass in 10 gram increments. But first we start with 0 grams, so we need to make sure that we put that in. So with this cell clicked on, so that we've got the blue rectangle around it, I'll just type in 0 and press enter, and then we have that entered as data in that cell. And let's say for that particular mass, the distance that we measure is 5 centimeters, 5.0 centimeters. Then we go to 10 grams and we measure 15 centimeters. So I'm just typing those in, and you can see you can quickly enter data very easily like this. Now we could go through carrying on this way, putting in 20, a new distance, 30, a new distance, or you may decide, well, you know the increments that you'll be using and you know the maximum mass that you'll be using. So we could type these in like so that all we have to do then is fill in the distance. Now of course this might change and you might have to change the mass values, but if you're confident that that's how the experiment can work, then you can do that. Now Google Sheets can help you with this, because once you've got more than one of these, if you've got a fixed increment in column values, what you can do is click and drag to highlight those two, or you could do more. And then you'll see that now there's a blue square that's appeared on the bottom right corner of the selection. When I move the cursor over that, it changes to a crosshair. Now if I click and drag that, like so, I've dragged down, can you see a dashed line that now occupies many more cells, and when I let go, it auto-fills all of those other cells, and it uses whatever increment was in the first two cells and adds those to successive other cells. So now I can focus on putting in my measured data of distance in each time. So let's say the data looks something like this. Hopefully you can see that there's a fairly simple relationship that I'm using here between the mass and the distance. Something like this, 76, 85.5. Of course, the experiment would usually take a lot longer than this. Oops, I've made a mistake there. So I can go back to it and write over it again. And here, do 105. Okay, so we have our data. But before we plot it, we might want to change the units. At the moment, we've got measurements in grams and centimeters. But let's say that we want to change the units to grams and, we want to change the units to kilograms and meters. Well, one thing at a time. So let's deal with mass in kilograms first. So we'll write in a new column heading. So mass kilograms. And we'll make that bold. Now we could do the calculation by hand and put in the new numbers, but much better for using a spreadsheet is to use some of the built-in functions to perform that calculation. So the key to using the spreadsheet is, if you want to do a calculation, you start with an equals symbol. So I'm going to put equals in. That turns on the internal calculator for that cell. So for instance, I could now put in 2 times 2 and press enter, and it will give an answer of 4. Now on this cell, don't worry, I'm going to erase this. I'm not converting to kilograms at the moment, just using this by way of example. If I don't put in the equals sign, I just put in 2 times 2 and press enter, it just sees that as text. It doesn't do the calculation. So you have to start with the equals. So I'm going to delete both of those entries. So we're going to start with equals. But look, what we can do now is click, while we've got the equals and the cursor flashing, click on the cell that we wish to do the conversion from. So that's this cell E2. Looks at E2 appears and it's highlighted now. So that tells us that E2, this cell, whatever value is there, is calculated in cell G2. And then to convert grams to kilograms, we need to divide by 1000, of course. So divide by 1000. And actually, this is a very unexciting calculation, isn't it? Because 0 divided by 1000 is, of course, 0. Okay, so you may think, well, we don't know if anything's happened here. Well, we can repeat the same process in the next cell along. So look, we'll press equals, then click in the cell we wish to calculate. This time it's E3, and then divide by 1000, press enter. Ah, look, 10 grams is equal to 0.01 kilograms. Okay, very good. But actually, it could be rather tedious to write that equation in every time, and we've got a fairly small data set here. So what we can do is instead click on the lowest cell here, and again we see that we've got the blue square, and we can move the cursor over the blue square so that the crosshairs appear. Click and drag. I'll just go a couple of cells down, and you'll see that the values are updated. And if I click on, say, this lowest cell, then here in this ribbon you can see what's been entered in that cell, and indeed it's here as well, and you can see that E5 is highlighted. So what happens by clicking and dragging using the blue square, I'll just press enter now, go back, you can see E5 there. If I go up one more, E4, E3. By clicking and dragging on the blue square, it automatically updates references to cells. So if I do it again, just go down one more, click and drag, 0.04, because it has updated the cell to E6. Now there's an even quicker shorthand, which is if you go over the blue square and double click with the mouse, it will automatically fill down to a point where the neighboring column finishes holding data. So all of this now is mass in kilograms. So let's do the same for distance into meters. So we'll put in a new column here, distance meters. So we've got the units. I'm going to make that bold again. So this time I'm going to convert these values in centimeters into meters. So I'm going to start again with equals. Then click on the cell I'm doing the calculation on, which is F2. And then I'm going to put in a conversion factor. So this time going from centimeters to meters, that is of course divide by 100. There we are. So we have 5 centimeters equal to 0.05 meters. I've shown you the shorthands already on this, so we just need to highlight and click on cell H2 where we've done that calculation, and then double click on the blue square in the bottom right corner, and all the values are now converted to meters from centimeters. Now we'll put in here, let's say we want to do some sort of calculation that combines mass and distance. So I'm going to call this, I don't know, important factor. And we're going to do actually mass times distance squared, let's say. So this will have units of kilograms meters squared. And this pointy up arrow called a caret, that is used as the symbol generally for something being to the power of, if you haven't come across that. It's because very often superscript, where you have a small number being raised a little bit higher, that often isn't available in spreadsheet packages. So there we are, important factor. Don't worry about what it is, I'm making it up entirely just to show you a bit of calculation. So I've made that bold. This time actually I made it bold by pressing Control B on a Windows keyboard. Slightly different on a Mac. It's the Mac key and B. And so this time we're going to do, with this factor, we're going to say that this is equal to 2 times, so I can use the asterisk as a times, and then I'm going to do times by mass in kilograms, times, again, the distance squared. So to do squared, I do that caret, that pointy bit again, and 2 for squared. Press enter. Well, that's not a surprise because we've got a 0 in there, so the whole thing is 0. If I drag that down 1 from the blue square, everything is updated and we see we've got a new value for the important factor. If I double click on the square, it will fill that whole line. Look, that's a lot of calculation done instantly for me. So I'm very grateful for that. However, I'm not going to use this data anymore. So I think it's going to be easiest now if I delete it. So it's just there for purposes of demonstration, but I don't want it to confuse us from the next part of the demonstration, which is making a graph or a plot. So what we're going to do now is plot the mass in kilograms against the distance in meters. So we've got these two columns here. We want to use all of this data, and we want to use the first row as the axes titles. So what we do is, first of all, click in G1 and then drag across to H1 and then down until we've highlighted all of the data that we wish to plot. Now we have to find where to plot. And the answer is it's this icon here, and in Google Sheets all of the plots are called charts. So insert chart, and we can also do this through this menu here. If we do insert chart, I'm going to use the icon here. It might not be visible, it might be just off the screen, but remember you can do insert chart from the menu as well. There we are. So the chart has now appeared, but it's not the type of chart that we need. because it's not showing our data points. And remember, your data are so precious. You've spent so much time obtaining the data, and the data actually represent reality. So we need to see them. So at the moment, this has come up with a line chart. Now, if you click on that, it's got that as the suggested chart. You need to scroll down until you see the scatter chart. And it's this left-hand scatter chart that you need in order to plot your experimental data. There we are. Now, at the moment, you can see some values on the left-hand side and no values on the horizontal axis. Sorry, values on the vertical axis, none on the horizontal axis. And what this is doing at the moment is plotting all of the data in the two columns, so mass and distance, against just the number of cells that contain data. So what we need to do is tell the computer, tell the spreadsheet that one of these, so the mass, is going to be the x-axis or the horizontal axis. So I'm going to click and drag the chart to move it down and out of the way. I'll move it to the side, look, and then I'm going to use the scroll bar to move things acrossways so we can see everything that's relevant. So then I'm going to go back to the chart editor, click on Add X-axis, and it says select the data range. Now you can click on this text box and enter the data range, or just click and drag within the spreadsheet like so, and that's the code. You don't need to worry about that, but that's the Google Sheets code for what I've just highlighted, and then click OK. Now you can see that we have numbers on the horizontal axis, but we still have two sets of data. We've got the blue data and the red data. So what we need to do is then only be plotting the distance data. So now look, we've got the two series being plotted here. We don't want to be plotting mass on the vertical axis. So series basically means what's plotted against the vertical axis, the y-axis. So I'm going to click these three dots and then click remove. So there we are. We've got now mass on the horizontal axis and distance on the vertical axis. So you can see mass going from about 0 to 0.1, just as in this column, and distance going from 0 to just over 1, which reflects the data that are seen in this column. But how do we know it's mass and distance? Well, it says so at the top, but if you were to come to this fresh, you wouldn't know which was which. So we need to label the plot appropriately. So to do that, we need to click on the Customize tab. Now chart style, I'll just open that and close it again. We don't need to change anything there, it's just theme colors and that kind of thing. So I'll close that again. I can click on the chart and axis titles. Now that is important to us. So if I click on now where it says chart title, I can choose which bit of text I want to change. So horizontal axis title, that is going to be mass in kilograms. And if I click away from that here, there we are, mass in kilograms has now appeared. And we can change the font of this if we want, and the size of it here. We can make it bold if we wish as well. Let's make it bold. There we are, mass kilograms in bold. And the vertical axis title, well, we go to this selector again. Now choose vertical axis, and we'll type in there distance, if I spell it correctly, in meters. And let's make that bold as well. Oh, I've missed one of the brackets. There we are. So we've got now distance and mass. This is looking a lot better. Mass, kilograms and distance isn't very informative though as a chart title. So normally here on the chart title you should describe what you've actually done. So here of course I'm making up the experiment, so I'm just going to call this made up experiment for Google Sheets demonstration. Like so, okay. And there it is, it's appeared there. And why not, let's make that bold as well. Okay, so we've got our data. We've got the axes labelled. Now, if you need to do a straight line plot, you can, of course, so I'll bring this back, you could print this out and, particularly at GCSE level, do a straight line from a ruler using your eye to judge where that line is. Now at A level, you will learn about least squares effect. So A level, for those of you not in the UK, is 16 to 18-year-old education in schools. Now if you've come across the least squares fit, you may need to use the data that's in the spreadsheet, but you could use the spreadsheet to help you do your least squares calculations. However, you can also use a tool within Google Sheets to do that fit for you. So to do that, you need to go to Series, and we're looking at the distance series. If you go down, scroll down, and you need to click on trend line. So we're just going for a linear trend line. If I click on that, you can see there's lots of others available, but I want to keep to linear. It knows that we're looking at the distance data because that's at the top, and then at the label here, so you'll see at the moment a line has appeared, which is great. Now you'll know for physics analysis often you need to calculate the gradient of the straight line fit. So to obtain the gradient, you could print it out and measure the gradient of the line, or you can click on this label selector and click on Use Equation, and then the equation of the straight line appears here. So look, you have the gradient 9.99 and the y-axis intercept 0.0491. And then of course, if you need to do some calculations, you can take that gradient and use it to calculate whatever it is that you need to know. So I hope that was helpful by way of introduction to Google Sheets, and hopefully you can see how you can take all of the flashy science experiments and record them in a Google Sheets spreadsheet, and then start to produce wonderful plots and do some meaningful analysis to get at the underlying science or engineering principles of whatever the experiment was that you were doing. So give us feedback if there's any tutorials that you think would be helpful to go through. Let us know and we'll see if we can post them. Okay, thanks very much.